Okay, one more video now with polar coordinates. In the last video we described polar coordinates and explained a few things, but now the main thing we want to do here is, one of the things they want to do is oftentimes you'll be given a point written in the XY coordinate system, so like 2, 5. And then what they will want to do is they will want to take that point and convert it into polar coordinates. So it's like, what would the 0.25 be if you wrote it in terms of r and theta? And likewise, they will want to take a point written in polar coordinates and rewrite it as an x and y value for that point. So basically, you could think of this as going, I could write it like this, going back and forth between polar coordinates and xy coordinates. Now, instead of just diving in and giving you the definitions, I want to point out something to you, because hopefully this will help. Because really, in a few minutes, when you look at the little formulas and definitions, it's going to look familiar, and that's because a while ago, when we did vectors, we wrote vectors like in the ij, and remember the ij, it's like the I you can think of as the x, and the b and the j is like in the y direction. And you know what we did? Say, I'll just call this vector v. We took this vector v written as ij, and we said we want to describe that vector in terms of magnitude and the direction of the vector. So we said, what would the magnitude of this vector be? And what would the direction be? And if you recall, in general, we said whenever you're finding the magnitude of a vector, I wrote it like this. You take the x part, you square it, and you add it to the y part squared and square root the whole thing. And then we said that to find the angle, you take the inverse tangent of the y part over the x part. And in the same way, if you were given the magnitude of vector w and the angle, and you want to rewrite that, in terms of I, j, sort of like x and y, then we had another little formula which says to write this in ij, you take the magnitude times the cosine of the angle, and that's your I part, plus the magnitude times the sine of the angle, and that's the j part. This should all be review. That's why we do it with the vectors. You're going to see in a minute, when we go back and forth between polar coordinates and xy coordinates, we're using the exact same kinds of equations and formulas. So that's why I want to show you this, because this is not going to be anything new. We've actually sort of done this before. Some of the notation might be a little different, but we've done it before. And that's because if we take a quick look, if we plot a point, if we plot an XY point, so here's XY, where there's my X, there's my Y. If I think of this, if I sort of draw this, I want to know what this point would be. If I'm given the XY, how can I write it in polar coordinates r theta? Well, if you think about it, what we're going to do is, here's my theta, there's my distance r. Just like we've done so many times, if we create a right triangle, the r, the distance or the length of my polar coordinate, is just the hypotenuse of this triangle. That's the same equation I just gave you a minute ago for vectors. And this angle here, I can say the tangent of that angle is opposite over adjacent. So therefore, if I want that angle, you take the inverse tangent of y over x. The same thing as you did with the vectors. So let's just do a quick problem or two. So how about I'm given a point 2, 5 in xy, and I'm asked to convert it to r theta. So 2, 5, just to get a maybe just to sort of get a glimpse. So there's 2, 5. So now I'm saying, what would it be in terms of r and theta? Well, r, the x squared, 2 squared, plus the y squared, looks like 4 plus 25, square root of 29. And I didn't bring my calculator, I should have. Here's a little calculator here, maybe I can use. Except it's so old, there's no square root. Maybe if I can pause this and get a calculator. So I've got my calculator now. So let's just see what square root of 29 is as a decimal. We'll just call it 5.4. Sounds about right. Now the angle, inverse tangent of y is 5, x is 2. Now I'm going to give the answer in radians. So make sure my calculator is set to radians. 5 divided by 2 equals inverse tangent 1.2 radians. And just for fun, let me do it in degrees to see if it makes sense. I have a better feel for degrees. So 5 divided by 2 equals inverse tangent 68.2 degrees, which looks about right. All right, not too difficult. Now the one thing is you got to be careful. We're working again with inverse tangents. So just for fun, let's do one more. How about I have the point 2, -3. The angle I'm looking for is going to be this angle here. And of course, r is just the distance. So I guess I could say, I should have wrapped this one up. Now that it's in polar coordinates, I could say the polar coordinate of that point would be 1.2, r is first, 5.4, and then 1.2 radians. Now for this one, 2 squared plus -3 squared, 4 plus 9, excuse me. So the distance or the length is 3.6. The angle, inverse tangent of y, which is -3 over 2. So let's do it in, what I'm going to do, just because I want to understand it, I'm going to first do it in degrees, just so I can see it, and then I'll give the final answer in radians, just so we can understand it. So if I do it in degrees, -3 divided by 2 equals inverse tangent -56.3 degrees. So that, once again, if you remember about inverse tangents, the angle has to be between -90 and 90 degrees. So what we're saying is this distance right here is -56.3, which really means the distance I'm looking for, I could take 360 degrees and subtract 56.3. So our angle is really, so I don't want to use that. Instead, I'm going to call it 303.7 degrees. Now, since I want it in radians, let's do the same problem in radians now that I sort of have a good feel for it. I just wanted to make sure I was on the right track. So in radians, -3 divided by 2 and then the inverse tangent. So it actually is negative 0.98. So now, if I'm in radians, what do I have to do? I really have to take 2 pi minus 0.98. Looks like it's 5.3. So my final answer would be R is 3.6 and the radians are 5.3. All right, so that's a couple examples of going from X and Y to polar coordinates. But now we also like to go in the other direction. So as our last example or two, let's look at a point given in polar coordinates and convert it back into XY coordinates. So we'll start with something fairly straightforward. How about 3 pi over 3? And we want to know what would it be in the XY coordinate system. It's always smart just to plot the point so you can make sure that your answers seem reasonable. So pi over 3 is right about here. Maybe we'll call 3 right here. So there's 3 pi over 3. And now it's pretty straightforward. The x is just going to be r cosine of theta. I didn't really show that, but if we go back to our original drawing up here, when we put an xy point here, and then we made a triangle, if for some reason I start out with the r and the theta, if I want to find this distance here, what do I know? I know the cosine of theta, so ca is x over r. And if I solve for x, r cosine theta. And if I want to try and get this other side of the triangle, I know the sine of theta, so opposite over hypotenuse, it's going to be y over r. If I solve for y, r times sine theta. And once again, if I look at these here, when I did my little, I don't have the vector comparison here, but it's just like vectors. Same exact thing as we went between I and j and magnitude of theta vectors. So anyways, r is 3 cosine of pi over 3. Make sure your calculator's in radians. Actually, unit circle, we should know this value. It's just 1/2, right? Three halves or 1.5. And then y is r sine theta. R is 3 sine of pi over 3, which you know is square root of 3 over 2. If we want a number for this, I can take square root of 3 times 3 divided by 2, 2.6. So I could say as x and y, this would be 1.5, 2.6. Now the nice thing, very last problem, you don't have to worry about goofy things going on with this. In other words, if I chose the point, how about I chose Oh, let's just be goofy. How about I'll call it -4 pi over 4, which is going to be right here. Let's see what happens when we apply our formulas. So x -4 times the cosine of pi over 4, -4 times square root of 2 over 2, it's like -2.8, and y would be -4 times the sine of pi over 4, -4 square root of 2 over 2. It's actually going to be the same point. So in this case, the x and y work out okay. In other words, in the previous problem, we had to worry about those inverse tangent stuffs. The nice thing is when you go from polar to x and y, everything takes care of itself.